In this video, we're going to go over the idea of a cross product of two vectors and then also work a few examples with those. So just a quick overview. The cross product is just another operation that involves two vectors. And this time, what it's going to do is it's going to find us, just to give you an idea, a vector that is perpendicular to both the vector u and the vector v that we are looking at. And the way to compute it is actually going to be based off of what we did in our previous videos with the determinant. And in order to use this, I'm going to go ahead and actually write our vectors using that alternative notation with the I hat, j hat, k hat. And so if I wanted to write u as u equal to ux I hat plus uy j hat plus uz k hat, and then similarly for our second vector v, we can define our cross product or compute our cross product using the determinant when we take the I hat, j hat, and k hat and stack that into our first, so that should be a j hat, k hat, that goes into our first row. And then our next two rows are actually just going to be the entries out of u and v. Just like so. And then all you have to do is take the determinant of that, which if we want to write that out, you get I hat times uy vz minus uz vy minus, because we alternate the plus and the minus, j hat ux vz minus uz vx, and then plus k hat ux vy minus uy vx. If you're into memorizing formulas, this is the one that you're going to want to use for cross product. And actually, if you kind of stare at it a little bit, you'll pick up on some patterns in the alternating back and forth between the components and then working with the I hat, j hat, and k hat. However, I am actually strongly discouraging memorizing this formula just simply because it is very easy to get some things turned around in it. So I recommend that you just simply start from this definition and go ahead and take your determinant, as opposed to memorizing a formula and trying to plug values in, because like I said, this one's really easy to get mixed up. So all of my examples are going to start with this and then actually just compute the determinant directly. Without anything else, we're going to go ahead and just launch into an example. So in this example, we have u equal to 0, 2, 0, and then v equal to 0, 0, negative 1. And we're going to try to find the cross product here. So following this piece up here, we're going to put I hat, j hat, and k hat into our first row, and then we put the entries of each of these into the second row. Notice that the vector that comes first is going to go into the second row, and the vector that comes second goes into the third row. That's going to wind up being really important, and I'll explain that in a little bit. So here we just compute the determinant. We get I hat, and then taking the determinant of what's left over when we ignore the row in the column that I hat is in, we're going to get 2 times negative 1 minus 0, and then minus j hat times the determinant of what's left over when we ignore the row and column that j hat is in. So we get 0 times negative 1 minus 0. That's just going to wind up being 0 here in a bit. And then plus k hat times the determinant of what's left over when we ignore that row and column. So 0 minus 0 times 2. Both of these guys just wind up being zeros. So we're just left with negative 2 I hat plus 0 j hat plus 0 k hat. So if we want to take this and rewrite it using our notation with the little angled braces, we can do that as well. It's just the same thing. Negative 2, 0, 0 is what we get out of that one. So all this is saying, though, is that we've just found this vector right here, -2, 0, 0, and it is perpendicular to both u and v. Let's work another example. This time, let's let u be equal to 1, 2, 3, and v will be equal to -1 to -3. So same idea. We're going to put I hat, j hat, and k hat in our first row, and then u goes into the second row, and v goes into the third row, just like so. We take that determinant, we get I hat times determinant of 2, 3, 2, -3, so we get 2 times 3 minus 3 times, 2 times -3 minus 3 times 2 minus j hat times the parenthesis, or times the determinant of what's left over. So 1 times -3 minus 3 times -1. And then finally we add to that k hat times the determinant of what's left over. So 1 times 2 minus 2 times -1. Simplifying each of these down and keeping with each of these components here, you get -12 I hat plus, this is just 0 right here, so 0 j hat, and then plus 4 k hat. And this right here is the vector that is perpendicular to both of those. So we can reformat if we want, but you definitely do not have to. -12, 0, 4 is perpendicular to both of those. Now, one thing that I want to point out is that the cross product actually gives you two vectors that are perpendicular to both of these. Because then all you have to do in order to get something, another vector that is perpendicular is, so we start with u cross v, but then also if we wanted to take v cross u, it's not equal to this guy right here. Swapping these two is not the same, which is really why it's important that you get your rows in the right order. And the way that they're related is that one points in just simply the opposite direction of the other, meaning that all you do is take one, multiply it by -1, and you get two vectors that are perpendicular to both u and v. Okay, so I'm going to do a quick example of how this would work. In this one, we are going to find two unit vectors, which is just going to kind of add another layer to this, that are perpendicular to the vector u equal to 2, 0, 0, and v equal to -1, 0, -1. Okay, so in order to get two vectors, like I just said, what we're going to need is, first of all, u cross v. That's going to give us our first one. And then our second one is given by flipping the order of those two in the cross product, which gives us -u cross v, like so. And then we will turn them into unit vectors. So this is the process we're going to follow. All right, so we're going to start by computing u cross v. This is equal to the determinant of the I hat, j hat, k hat in the first row, and then we put u into the second row, v into the third row, like so. Take that determinant, and we get I hat times 0, -1 minus just 0 minus j hat times 2 times -1 minus 0, and then plus k hat times, that's just going to be 0 minus 0. So that particular vector, the perpendicular vector for these two is going to be 0 I hat plus 2 j hat plus 0 k hat. Okay, so what that means then is u cross v is equal to 0, 2, 0. All right, so that's our first one. Then to get our second one, all we have to do is take -1 times this. You do have the option of walking all the way back through this process, flipping u and v in that determinant right there, but it's way easier if you simply take v times u is equal to negative u times v, which is going to be that 0, 2, 0. So we're going to get 0, -2, 0 as being our other perpendicular vectors. Okay, so that's step one right here. Okay, we got these two pieces. We've got our two perpendicular vectors. All we have to do to finish this example is going to be to turn them into unit vectors. And the way that we do that is just dividing by their length. So for our first one, we're going to have 1/2 times 0, 2, 0. And then for our second one, we have 1/2, 0, -2, 0. This 1/2 that's out front here, that's just simply the length of each one of these vectors. Notice that multiplying by -1 had no impact on the length of the vector, just simply because negatives don't change the length of the vector, and then multiplying by 1 isn't going to change the length of the vector at all. So our two vectors then wind up being 0, 1, 0, and 0, -1, 0. So these are our two vectors that are perpendicular to the two vectors that we started with, and also we've now made them to where they're unit vectors by dividing out by their length. So that's all the examples that I have for working with the cross product. In the next video, I'm going to talk a little bit about the geometric interpretation of the cross product beyond simply being the vectors that are perpendicular to the vectors that you're working with. All right, see you next time.